show that it's happening. Okay, cool. Okay, so when I schedule the next one, I'll share the link in the Teams as well, because then it's easier to get in from Teams, and I'll share it on some of the other platforms like WhatsApp and things like that as well. Okay, so basically last week, with all the interruptions, we started with study unit 5. So I just want to nearly end study unit 5 today, because then we've done study unit 4 and 5 that you can then submit assignment 2 as well. And then we take it from there, because assignment 3 is only due end of June, I think the 30th of June. So we will then have enough time to work through that as well. So I just want to nearly, let me quickly get where. So last week we ended off with this question, but I just want to nearly re-look at it, so that we then can go into the next one, and as people join, that they don't miss too much of a new discussion. So basically so this is interesting. So it is all the new things in Microsoft. Okay, I should have looked at this before I started, to see where is the pen and all of those things. Okay, I will sort this out as we go along. This is now quite interesting. If anybody knows in Office 365 where this is. This is quite interesting. So obviously I haven't worked in a new office environment. Yes.
What are you trying to do?
There's normally a pen and a highlighter that you can work with in the old PowerPoint.
Isn't it under, yeah, you're already under format picture. Oh, yeah, under format picture.
So let's, so let me quickly just, otherwise I am going to Google that. Okay, so it's not in there. Definitely not in there. Not in there. It's supposed to be with the inking. Okay, this is now going to be interesting. Okay, I just know. If anybody else know how to do it, let me quickly Google.
Yeah, I'm busy looking this side as well, but I'm not seeing it.
I see a draw there. Okay, this is not cool. Okay, so that is just okay. There needs to be a draw function next to the review. There should be a draw function, which is obviously not being activated. Okay, we'll manage. There's other tools that we can use as well, so we'll manage for now. I'll see how we can sort this out. Okay, so just to get back to question 2. So in
Gene,
yes.
have you maybe tried right-clicking on your mouse and seeing if there's other options available there for you?
Okay, that will be awesome. So let's see. Yeah, no. So no. It's probably one of the settings that hasn't been activated, because we're supposed to be. If I now look at what Google's also say, is we're supposed to be a draw. And I don't know how to activate that now. So let's quickly see.
I found it there, John.
Okay.
Okay, so going to your, let me just check, by home, you've got the tab at the top that says drawing. Right click on that so that it opens up customize the ribbon.
Okay, so say at home.
Yeah, so go to home.
Yes.
Tabs at the bottom, so you got font, paragraph, and drawing. Go to drawing and then just right click on it so it says customize this ribbon.
Okay, see, so let's quickly customize this ribbon.
Yeah. Okay, does it open up?
Yes.
Okay, then you go to not popular commands. You see there where it says choose commands from. Then you just go all tabs.
Yes.
Okay, then on the right hand side it will pop up and it says there home, insert, and draw. Just tick that draw box.
Ah, it is awesome.
Then you will have draw with all your pens. Got it.
Okay, so let's just quickly see. So I did, there is draw. Awesome.
Cool. There we go.
Cool.
Okay,
and you guys.
Nine is make me pass. Eh?
Yes. And you guys can see the screen.
Yes.
Okay, awesome. Hey. Okay, so basically when we work out expected number, it is, and I looked at it where I don't remember these things. You also don't need to remember it because we have it in all of our documentation. So expected mean is n times the pi. So let's look at what we have. So it must be n times. Okay, so we'll do some of those also now and see what I get. So n will be in it. So if a backyard farmer planted 25 seeds, so that is n. And they tell us that it happens 90% of the time that it will actually develop into a plant. Okay, so then it is for 25 times 90%, which will give you the answer of 22.5. So that is just to quickly come back to how we would have worked out the expected value for x. If we needed to work out the variance, because that can also be one of the things that we ask. So if we work out the variance, it basically is the expected and the extra thing that we add is 1 minus the expected. And now also nearly what you need to remember, they can ask you the variance or they can ask you the standard deviation. And if it was the standard deviation, it is just basically the square root of the variance. Okay, so sometimes they can ask you the standard deviation, sometimes they ask you the variance. Okay, so that basically nearly covers most of the things that we need for binomial, but I think there's probably 1 or 2 more that I added that we can just look at basically again how you would use the table to get to this. Okay, so suppose that 10% of butterflies have damaged wings. If a random sample of 10 butterflies is selected, what is the probability that more than 4 have damaged wings? Okay, so basically, and again now, when you look at your table, so let me quickly see if I can get where the tables are. I just want to show you something which can also be sometimes confusing if you look specifically the binomial, because also when you work with okay, not too bad guessing where it was. Let's just see. Okay, so when we work with, and this one, let me quickly just see, the sample was 10, so let's just get back to sample 10. Okay, so here we have the sample 10. We were looking for 10% butterfly. So what you sometimes will also see is that at the top, because it was part of a previous page, sometimes they don't give you the information, but what they do give you is at the bottom they give you information. So what you need to remember is, if you look at the bottom part, with all of the probabilities, what is reflected above will be, say, 10%. What reflected below is just what you needed to add to that 10% to give you to 1. So if we have a value of 0.9 at the bottom, it would have been that at the top, it would have been actually 0.1. So that is just important. So when I have this table, you don't see 0.1 at the top, but actually it is 0.1 there and 0.9 at the bottom, because the 2 will add to 1. So just important that sometimes when you also, at least for the exams, you can actually create your own tables. You can have it with you. I will send you some of the tables that I also have, and what I will do is I will make some notes on the tables for you as well, because that will just be easy in any case for you. So I will do that. I'll just get a nicer table that actually everybody can see, and then I will make some notes on that, and I'll scan it in and and also send that in a PDF so that you can have that for your exam as well. Just that you have something that you don't now need to go in the book and look for it, that everything is just together. Because normally how it was is that your assignments was in like a small study guide or booklet with all the tables at the back of all of those assignments. So that was one easy booklet that you could have to use in the exam. So I will just prepare something for you that you don't need to use your book and scroll between all the different pages to find what you need. The lecturer will also, a month or two beforehand, will nearly give that table to you, but maybe I will ask him to, if we can get that to you guys earlier, that you can just use that when you in actual fact do some of the assignments as well. Okay, so basically what they want us to do, they said look at the 10% where n is equal to 10. So we have n is equal to 10. We are looking at the 10%. What is the probability that more than 4? See, now it becomes a bit tricky. So what does more than 4 means? So more than 4 means that you're not including 4. So it is 5 and above. Okay, so 5 and above is basically those three added together. So more than 4, so you don't include 4. So it's 5 and above, so it is 0,0015 plus 0,0001. There's nothing there, so your answer is 0,0016. If you have added that one, would there have been an answer? Yes. It would have been option 2. So if you did say, okay, but more than 4 means I need to include 4, then there would have unfortunately been an answer for you as well. If you only looked at 4, there was an answer as well. If you did it the other way around, to say that the probability that more than 4, and you actually said up until 4, there was an answer as well. Okay, so nearly, and that is nearly the not the problem, but the difficulty with binomial Poisson and even your normal distribution that we will get later to, is that there's for each mistake that you can make, there is an answer. And unfortunately, because there is an answer, you will think in the exam as well that, okay, but I'm actually correct. And I think that is just sometimes the difficulty with this subject, is that there is nearly for any possible logical mistake that you can make, there is another option. And yeah, so it's very important to be very clear what we are looking for. Okay, so let's quickly, I think there's 1, 2, I still got 2 binomials. Okay, so let's look at what is in the next one. So using binomial distribution, n equal to 4. So on the table we have n equal to 4, so that's the first thing. Pi is equal to 0.2. So let's see. Okay, 0.2 is at least on this. So we've got 0.2. So we will work within that table or within that column. So we're not looking at any other of the columns. We're only going to work within that. And then we need to find the probability that x is smaller than 2. So if it's smaller than 2, which ones do I need to add together?
0 and 1.
Okay, awesome. So we basically need to add 0 and 1.
Not at the top, where n equals 4.
Thank you. Okay. Luckily, luckily there wasn't an answer for that. But that could also be just because that is quickly how I wanted to do it. Thank you. Okay, so it's basically those two. Okay, so that will be, let's quickly, 0,8192. If you added 2, that would have been your answer. Okay, so if you said no, but 2 is part of this that I need to work out, there would have been an option for you as well. Okay, so again, it's create must be smaller than 2, so we don't include 2. But again, very easy to make that mistake by saying, okay, it's from 2 and below, and then there is an option for you. Okay, so let's look at the last one for binomial.
John?
Yes.
So just before you go, why don't you go back to question 3? For some reason, I saw pi as 90.
See,
sorry, as 0.10.
See,
so,
it is 0.10, but in some of your tables, it's split over 2 pages or 3 pages, and then there's nothing at the top, but there's 90 at the bottom.
Okay, yeah, because okay, yes, I understand what you're saying. Yeah, because I did take the top and I did look at 10. Okay.
Yeah.
All right.
See, so and that's why I want to nearly get you guys a decent table that you don't need to nearly think where this is now, because that was in a previous textbook, or I think it's in the study guide where it's split like that.
Yeah, it is. Yeah, on page 91.
And that is very easy to make a mistake if you're working in the exam now with this. So yeah, so that's why I just want to nearly get you guys something that's just easier to work with. That you don't need your tables to still make you wonder. When you're in the exam, that needs to be correct, that you can just get to the answers.
Perfect, thanks.
Okay, so let's look at the last one for binomial, and let's see what they have in here. According to a report, 20% of South Africans delay or go without medical care. Suppose 6 individuals are randomly selected. The probability that more than 4 will delay. Okay, so 20% seems like 20% is one of the things that they like to work with. N is 6, and they say more than 4. So more than 4 again is 5 and 6, which will give us those 2 that we need to add. And I think that will give you that answer. Interesting to see. So if we only looked at 4, there would have been an answer. That would have been 1 minus, say, if it is less than 4 or less than 5, actually. So again, other options possible. But the other thing that is also interesting sometimes, and just because one is so used to they give you everything in this one, 10%, 10 butterflies. So sometimes with the being written in words, you can also sometimes miss it because one is so focused on where's the numbers, but sometimes one does miss a word that you are looking for sometimes. So just be on the lookout for that as well, because that's just another thing that, again, when you're sitting in the exam, and because normally how I would have started is to look for all the numbers. And then sometimes if it's written in words, you just glance over it and not always seeing it. Okay, so again, question 7 for the binomial, or question 6 for the binomial, was in a sense straightforward, but please use the tables. Don't try to do this with a formula or calculator or anything, unless there's an online calculator that you can just type in those three variables. Otherwise, use the tables. Okay, then we go to Poisson. The difference and nearly how you must nearly recognize the difference if I don't tell you it's Poisson. Most of the times they will tell you if it's a Poisson distribution, but if I don't tell you, the thing that's the difference between Poisson and binomial is that there is a time linked to it. So you would, if I quickly go through all the binomials that we did, it just tells you random variable n pi, go and look for something. Germinates, so they give you the probability, they give you the n, they don't say per day, per night, or anything. When you look at this one, it was for 10 butterflies, 10%, with n find the sigma, or sorry, the pi with a number the same year, 20%, there's no over a time period. Then suddenly in Poisson, there's a time period. So question 1 was per day. Let's look at another time period. Per month, let's look at another one. So here they don't tell us because they're asking us for something different, but they give us that. And let's look at the last one, per minute. Okay, so the difference between binomial and Poisson is that with Poisson, there's always an indication of time. So it can be per day, per year, per minute, per second, anything like that. So just remember the difference between the two. Okay, so then on the Poisson side is that, again, from the tables, and these tables are a bit easier because we're only always looking at that. So we always know that, and the other thing that we need to remember about Poisson is that the mean and the variance are equal. So again, worst case is that they tell you in the exam the variance is equal to something. But then you need to remember, okay, variance is equal to mean, and that mean is equal to the lambda that I'm looking for. So worst case is that they refer to it as variance. I must be honest, I haven't seen in any exams yet that they do that, unless it's more than just a probability. So we'll get to one of these that talks about the variance, but I haven't seen that in the heading nearly of a question that they say a Poisson distributed with a mean, with a variance of something. But if they do just be prepared for it that the variance is equal to the mean. Okay, so what they tell us to do is calculate the probability that 3 bank robberies occur in a day, where the number of bank robberies that occur in a large Gauteng city is Poisson distributed with mean that equal to 1.8. So we've taken from the table where lambda is 1.8. So if they tell us calculate the probability that 3 bank robberies occur, what would you do? How would you look at this one, and how would you calculate that number for free bank robberies?
I would see it as equal to 3, so only taking the value next to x3.
Okay, awesome. Okay, so they could have said more than, they could have said less than. Here they only say 3. So then you basically take that one value next to 3, which is 0.1607. And I think that is nearly, again, so it's more about the terminology that nearly can make it difficult in these questions. So let's look at the next one, and let's see what they are looking at or asking this time. So Poisson, suppose the faults occur on average. Average we know is exactly the same as mean, so that is your lambda. So we have already picked the lambda of 2.5, the probability that at least 2 faults are found. Okay, so now open to you guys. What at least 2 faults? Anybody?
So what is that, equal to or less than? John?
Okay, so anybody else? Okay, so
I think it's exactly 2.
Okay, anybody else?
I think we say 2 or less. I think we include the 2 as well.
Okay, so basically the same that, is it Greg? Set.
Yeah, it's Craig.
Greg, okay, cool. Okay, so at least 2 means that the utmost minimum mistakes is 2. So you can't make 0 or 1 mistakes, but it can be 2 faults, 3 faults, 4 faults, or more. Okay, so at least 2. So it is nearly, and sometimes I look at this and I want to make it easier for myself, because let's be honest, Afrikaans is my first language, so English, when it starts giving me these words, I'm also getting confused. So when I look at it, I'm like, okay, how can I explain it to my son? So for me it is, and if I tell him that he can get himself chocolates, at least 2 chocolates, then he will always pick 2 or more. And that is nearly how you need to look at this, at least 2. But then, if I say at least 2, I must add all of these together. And there's no ways in the exam that I am going to add all of these together, because that will just, again, somewhere I will make a mistake, and somewhere I will just, so instead of adding all of these together, I just say 1 minus and adding those 2. So if I add those 2 together, And let's see if this works a bit better. Just right. So if I add those two together, I get 3, I get 7, I get 8, I get 2. Huh, interesting, there's not the answer for that. That is quite interesting. I would have thought that that would have been one of the answers. Okay, so those 2 is equal to 0,2873, but I want to get that part, so I need to say 1 minus that. So if it is 1 minus that, my answer will be 0,7127, which is option 1. I am really surprised that that was not one of the options. And you will also see what happens a lot in some of the answers is that they would nearly just turn 1 or 2 of the numbers around, because again, very easy to, when you jot down a number or remember a number, you can very easily just swap the 2 numbers around. Okay, but I must say I am quite surprised that, so that was one of the options. I am quite surprised that that wasn't an option if you just added the 2. Quickly, everybody happy with that? And I think that is why it's important nearly to get these more than, at least, most than, kind of, and hopefully I've added some of the other wordings as well. But I will go through some of the previous exam examples and check for a few of those, that we can just nearly sort that out. Because that is where they're going to want to catch you out in the exam. It's not about nearly understanding the work. It is going to be with that and how they phrase the question. Okay, happiness with question 3. Cool. Okay, so let's look at question 4. Okay, so question 4 is also an interesting one, because they give us the lambda.
Sorry, Jean,
Yes.
can we quickly go one back? I just want to double check myself. If they
This-
were asking, yes, if they
Yeah.
were asking the probability at least 4, would we then have added 0, 1, 2, and 3, and then minus the 1?
Yes. Yes.
Okay.
See, so, and it's normally if there's 12, I normally, depends on where it is. If it was here in the middle somewhere, then I would just say, okay, let's just add those together if needed, or if I needed to look at the bottom. But there's just no ways out of 12 that I am going to add 9 or 10 of them. So I would probably, up until 4, 5, would still do it 1 minus, and then from 6 I would just say, what the heck, let's just add it. But you will also nearly note, and it would be interesting to nearly know, and yes, I will only know afterwards in the assignments how they actually have asked it, because again, they would, what I've picked up is, and it's the same with nearly when you need to work out mean and variance that we did in study unit 3, they're not going to ask you to do it with a sample of 50 or 20. It will be with 3 or 4 or 5 numbers. The same year is, they will not ask you to have it with 5, because then either or, either way you're going to do it, you're going to add a lot of numbers. So they would rather do it with 1 or 2, that they can test that you can also nearly say 1 minus those 2. So the idea is not that they want you to make a mistake in adding all of those together and somewhere just make a mistake. It's rather to get to the shortcut. Okay. See, so again, if you look at this one with lambda equal to 6, so it goes up to 17. So again, they won't expect you to work out what's the probability between 3 and 14, because that is just, again, too much. Okay, so let's look at, I'll first run through what I need to do, and maybe there's something pops out that I don't need to look at it. So, okay, probability, I need to look at that. Variance, okay, so I don't need to look at that, so we'll come back to that. Probability, probability, probability. So all of them, except number 2, I will need to use the table. Okay, so lambda equal to 6.0, we know that lambda is equal to the mean, which is equal to the variance. So variance should be equal to 6. So the first one, it is wrong. I don't know if the square root of 6 is maybe equal to 2.45, which it probably is. So then that 2.45 is probably standard deviation. If somebody can just check for me if the square root of 6 is 2.45.
That is correct.
Okay. So again, nearly testing something with you on the theory of it, because again, easy to make the mistake to say, and somewhere you forgot that lambda is equal to variance and you maybe said it's equal to standard deviation. But that is the wrong one, because the variance should have been 6. But let's look at how to get to the other answers, because I think that is again where the practice comes in and the understanding comes in. So when they, and let's use a different color. So when they say x equal to 0, then we only need to look at one number. So we look at where x is equal to 0, 0,0025, that is correct. Okay, so that is not 1 that's equal to 0, not. Okay, so we'll need to make a few calculations. X smaller than 3, so x smaller than 3 basically is 2, 1, and 0. Okay, it doesn't include 3, otherwise it should have been smaller or equal to 3. So smaller than 3 is basically 2, 1, and 0. And if we add that, we will get that answer, because it's 0,0446 plus that gives us that answer. Okay, and Christine, now it's nearly something that you also referred to the previous one. So bigger than 5, again, so it is 6, and so again, there you need to nearly add 11 probabilities, and I don't want to do that. So I would have then rather said 1 minus and adding this group of probabilities, which just makes the chance of the error or making a mistake just less. Okay, so that then would add up to 1 minus that would add up to 0,5543. And it's quite interesting, so let's quickly see. So there's the biggest difference. So that would have been 2929 plus that would have been 3741 4 to, it could be close to 4, 5. So 1 minus 4, 5 will give you that. So that is also correct. Then the other one is to say, but let's look at, let's look at if we need to get to something that is in between. Okay, so smaller than 5. So let's look at smaller than 5 is basically from 4. Bigger than 2 is from 3. So basically we're only looking at 3 and 4. So between 5 and 2 is 3 and 4. So we need to add those two together. Which is interesting because that would not add up. Okay, so that is also, that is quite interesting. That should have, and I didn't know with this move, it's still all in line. Yeah, so that is actually a mistake on the, so we need just, I will flag that. So that is definitely a mistake in the extra guide. Because that answer should have been, what is it, 1 to that side, it's 3, 9 plus 3. Yes, you can ask, don't worry, you can go ahead. Yes, please ask a question.
Yes, I wanted to say something. That option 2 is correct because the calculation of 6 is indeed 2.44 something, so it's round off and then it will be 2.45. So option 2 is also correct.
Can you quickly repeat that? I didn't hear.
I'm saying option 2 is also correct. The only option that is wrong is option 2. Because if I put a square root of 6, the answer is 2.449. If you round off, it will be 2.4.
Okay, but remember, then you've calculated the standard deviation.
Okay.
Where the rule is, so let's quickly go back to, and that is why you can, so the rule is the mean and the variance are always the same. So the mean and the variance are always, yes. So they give us the mean.
I just want to check something. Is it possible to calculate it, the smaller than 2, to take the 1 and the 0 and add it, and then also add the separate one for the smaller than the 5, and then add all those together?
Yes, you can. So you can, let's, okay, why didn't that now? Okay, so let's just do that. I don't know why. So you could, and let's just move that. So you could, so say that again. You wanted to say you you add all of those and you subtract those ones. Is that what you are saying?
My signal got a bit lost there. I'm asking if you first work out the first part of the probability, the 2, and if you add the 0 and the 1, and then work out the 5, which will then be from 0 to 4, if you calculate those separately and then just add them together.
Oh, yes. So then, but see, what you need to remember is, so if you say bigger than 2, you're going to say you need to say 0, 1, and 2. And not just go 0 and 1. Do you understand that, Christine?
Yeah, so by then you'll have to add the 2.
Yes.
But shouldn't it then be equal to as well? Smaller and equal to then?
See, so depending on what they say, so if you, so you can, you could have said, I add all of the x's that is smaller than 5, which would have given you all of the x's smaller than 5, and you get the answer. And then you say, okay, but let's then say, what is the other part? So then all of the x's that is up until 2, and you get the answer. And though that answer minus that answer would have given that as well.
Okay, thanks. That's the answer I was looking for.
Okay, so you can do it that way, because what you will see is that component is in that one and it is in that one. So you are then left with a 3 and 4. Okay, Vugani, was that and sorry if I pronounce your name wrong, was that an alt-ant? Are you okay now, or do you still want to ask a question?
No, I'm okay. That's what I'm okay.
Okay, cool. So I think the important thing as well with Poisson is definitely there's going to be that instance where they want to catch you out with the variance, the standard deviation, and the mean. So that's for one point, and this one is wrong. So definitely I will just flag this to the lecturer as well, that they can send out a note. Okay, let's look at the last one. I just want to know, why did that was just a bigger one that I can also see what I'm looking at. So a cashier total average of 1.2 trays per minute. Okay, so we're looking at 1.2. Which one of the following is incorrect? Okay, the problem follows a Poisson distribution. Okay, remember, they're not going to give you in the exam the table like I now included it with the question. So it's not that we can say, oh, but there's the table. But in what they were asking is how many trays per minute. So that per minute gives you the indication that it is Poisson distribution. So that is correct. So that is purely definition. The variance of this problem is 1.2 trays per minute, which is correct. Purely from a definition, the average or the mean is equal to the variance. Then they ask you 3 probability questions. So let's first, I want to see if there's any ones that ask me equal to. the probability that the cashier would total exactly 0 trays, exactly is equal to, so total equal to 0 trays. 0 trays is 0,3012, correct. The probability the cashier will total at least 4, so we need to work out something there, at most 3. So basically we're now covering nearly all the words that they can use in the exam. So the probability that the cashier will total at least 4. Okay, so at least 4. Anyone, what do we need to work out?
Hello?
Yes.
If they say at least 4, then which means it includes all that is from 4 up and above. That's, I think it's the same as what you
Cool.
have explained.
Cool.
And what
Awesome.
we're gonna do, we're gonna say 1 and minus the everything that is above is below 4.
Okay, see now this perfect. So I would have done that. What is interesting is that the last 2 is actually 0. So here you can add those 4 because it will be exactly the amount of how much you would need to add at the bottom as well. But just because those 2 are zeros, otherwise I would have also said 1 minus, because then I needed to add more. So this one, 2, 4, 6. Ooh. So maybe there was a mistake. Incorrect one. Because it's 2, 4, 6. 6, 3. And then, okay, this is quite interesting. And was this the same numbers?
Yeah, if you minus the top, the below ones, which gives you the 0.338.
Yes, so this is actually not 0.0000. It should have been a 1 and a 1, because that was, now I know when I worked it out the other way, it actually, so if you set 1 minus those 4, it would have given you the 0,0338. Okay, so this is a bit, hopefully something like this doesn't happen in the exam, because I would have even just added those because there wasn't any numbers there. So it should not be something like that in the exam, that you can maybe say that is incorrect. Okay, most free trays. So most free trays, what would we do for most free trays?
Can I try? Most 3 trays, it will be anything from 3 to below.
Okay, awesome. So at most free, so maximum free. So and that is interesting. So basically what we've worked out originally to -1 should have been this answer. So what the difference is probably is that has been subtracted from the original, which is going to be 0,9662 or something like that. So if I subtract that from there, that is the difference. So in this answer, they actually went most free, so they said not more than 2. Because if you add those 3, it would have given you, but you should add 0, 1, 2, and 3. Okay. So basically, when you look at Poisson, the most difficult with a Poisson is actually more in the wording than anything else, because if it is in this where they tell you smaller than or bigger than, then it's easy, but when it becomes the wording, then it is a bit more difficult, and that is nearly the part that is the most difficult in the Poisson distribution. Okay, everyone, it is 7 o'clock. We are finished with this at least. We've done now discrete, we've done binomial, we've done Poisson. So this is basically for preparation for your assignment 2 as well. Yes, Fuzi.
Yes, I think number 5, I don't get it. What did they do? Can you just repeat that for me? Sorry for that.
Okay, no problem. So for 5, will total at most 3. So at most 3 means that you need to add up until 3. So the maximum number that it can happen is 3. So what they did to get to that answer was they just added up until 2. So they left 3 out. So that is where they got that answer. That is why that answer is wrong, because it should have included 3. Because at most 3 means maximum of 3.
Oh, yes. No, now I get it. That is the answer we were looking for.
Yes, yes.
Okay, correct.
And that is also sometimes when you look at incorrect and correct, that can also confuse you, because you knew exactly what you needed to get. So yeah, so I think that is also the thing that one needs to just be careful in the exam. Okay, so I'll schedule a session for next week that we can start with study unit 6, but just remember that for now, the due date for assignment 2 is still 31 May until they communicate anything different. It is weird, but that is what it is at the moment. Okay. Any other question, guys, before we finish for the evening? Okay, nothing. Then have a good evening, and we'll speak again next week. And I'll see how quickly we can get this recording onto the YouTube as well.
Thanks, Gene.
Thank
Have
you
a
very
good
much,
evening.
John.
Cool. Thanks, everyone. Have a good evening.
Thanks, guys.